Chapter 9, Circles. Today we're going to cover Section 9.5, Inscribed Angles. Your class opener. Find the measure of each central angle. Section 2 deals with inscribed angles. Your objective will be to solve problems and proof statements involving inscribed angles, and to solve problems and proof statements involving angles formed by chords, secants, and tangents. Inscribed angle. An angle whose vertex is on a circle and whose sides contain chords of the circle. So if I were to draw an inscribed angle, the sides are chords and the vertex of the angle happens to be on the circle itself. So the most important thing is I'm thinking the vertex is on the circle. Theorem 9.7. The measure of an inscribed angle is equal to half the measure of its intercepted arc. So if I start by drawing an inscribed angle, and if I were to tell you that the arc out here is 60 degrees, then I know the inscribed angle is half that size, and it would be 30 degrees. Corollary 1. If two inscribed angles intercept the same arc, then the angles are congruent. So if I think of looking at, say, an arc that's that big, and I want to draw in some inscribed angles. Well, let's say one inscribed angle is up here, and that the second inscribed angle actually comes over here. Well, these two inscribed angles should be the same size, and the reason I know they're the same size is they're both half the size of the same arc. So if I came in here and actually picked some values, if I told you that this was a 140 degree arc, well, each inscribed angle is going to be half the size of that arc, and they're both going to be 70. So even if I didn't tell you the number values, if the two intercepted, or the two angles are both from the same intercepted arc, the angles are going to be the same size. Corollary 2. An angle inscribed in a semicircle is a right angle. So if I think about drawing in my semicircle, and then think of inscribing an angle, I know that if I inscribe an angle, no matter how I draw it, the sides of this angle are determined from an arc that's 180 degrees, and an inscribed angle is half the size of the intercepted arc, so it's always going to end up being 90. Corollary 3. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So I'm going to start by just making a random quadrilateral. So I need a four-sided shape that is inside of here. Purposely going to make them not look like they're the same angle sizes. So this corollary is saying that opposite angles are supplementary. So let's look and see why that's happening. So if I randomly pick two of the opposite angles, let's say this angle down here and the one at the top, why should those two angles be supplementary to one another? Well, if I think of the angle up here at the top, that angle is going to be half of this intercepted arc that's down at the bottom. Likewise, the angle down here at the bottom is going to be half of the intercepted arc that's up at the top. Well, the two arcs complete an entire circle, which means the arcs add up to 360 degrees. So the angles, which are adding up to half of the arcs, will add up to 180 degrees. So right away, if you see an inscribed quadrilateral, opposite angles are going to be supplementary. Find the measure of angle 1 if, for number 1, the measure of arc BC is 60. So I'm just thinking if arc BC is 60, angle 1 is going to be half that size, and angle 1 is going to be 30. Number 2. Well, how big is angle 1 going to be if I know that arc BAC is 250? Well, if all of this coming around is 250, I know that a complete circle is 360, so that must mean that BC is 110. And now I know that angle 1 is half of 110, which is going to be 55. Next part, find the measure of arc BC if the measure of angle 1 is 50. Well, if I know that the angle is 50, I know that the arc is going to be twice the size, so it's going to be 100. Number 4, find if measure of angle 1 is 27. Well, again, the arc BC is just going to be twice the size of that, which would be 54. Find the values of W, X, Y, and Z. All right, let's see. If I want to find angle W, I know that it's going to be half of the intercepted arc, which is out here. So how big is that arc? Well, I see the top half of the circle is a semicircle with an arc on the top left being 100. So that must mean that the arc over here is going to be 80. And I know that half of 80 is 40. So W is going to be 40. X, well, X is a central angle that intercepts the 80-degree arc, so X is going to be 80. Let's see Y. Y is the arc that is intercepted by an inscribed angle of 43, so Y is going to be double that, which is going to be 86. And the only thing left is to find Z. Well, I know that a complete circle is 360. If I look at the arcs, I currently have 100, an 80, and an 86. So far I'm up to 266 degrees. I know a complete circle is 360. So if I just subtract, I get that Z is 94. From a point on a circle, draw a chord and a tangent. Let's see, I'm just going to pick a point here. If I draw in a chord, I'll pick there. A tangent's going to look something like that. And this brings us to Theorem 9.8. The angle measure of an angle formed by a chord and a tangent is equal to half the measure of the intercepted arc, which hopefully makes sense. It's sort of like saying if off to the right over here, if I have an arc that is 90 degrees, the angle in here is going to be 45 degrees. So it's just like an inscribed angle where the angle measure is half of the intercepted arc. Find the value of X, Y, and Z. Well, let's see how I can do this one. I know that X is an opposite angle of an inscribed quadrilateral to the 82. So I know that X and 82 have to add up to 180 degrees. So that must mean that X is 98 degrees. And if I go for Y then, well, here's something I noticed. Angle Y and angle Z are both formed by chords and a tangent. So they're going to be half of the intercepted arcs. Since the intercepted arcs for each one of them happen to be associated with congruent chords, I know that those arcs are going to be the same size. So what I'm going to do is look at if X is 98 degrees, the large arc across from it is going to be twice the size, but then I'm going to divide it equally between these two. So each of these arcs is going to be 98. And if I want to find out how big angle Y and Z are, they're half the size of the intercepted arc. So each one of them is going to be 49. Number 10, prove. If two chords of a circle are parallel, the two arcs between the chords are congruent. So I have my given and prove statements. I'm going to fill that into my statements and reasons column. And I know my first statement always ends up just being my given. So segment AB is parallel to segment CD. And I'll fill that in over here. And that's given. I want to prove that arc AC is congruent to arc BD. So the easiest thing that I can think of is, let's start by drawing in an extra piece. I'm going to draw in from B to C, or I could have drawn in from A to D. It really doesn't matter. So I'm going to write in draw in segment BC, and I know that by 2 points determine a line. Now I notice something sort of interesting. Since I have parallel lines, I know that alternate interior angles are going to be congruent, and I'm just going to number these angle 1 and angle 2. So angle 1 is congruent to angle 2, and my reason is if I have parallel lines, then I have alternate interior angles congruent. Well, if angle 1 is congruent to angle 2, and I know that arc AC is twice the size of angle 1, and arc BD is half the size of angle 2, I should be able to get that the arcs are the same size. So let's see. So for step number 4, I'm going to write that the measure of arc AC equals twice the measure of angle 1. Likewise, the measure of arc BD is twice the measure of angle 2. And I'm just going to write down an inscribed angle is half the intercepted arc. And now I can sort of by the transitive property or by a couple substitutions get that the measure of arc AC equals the measure of arc BD, and it's really the transitive property a couple of times. And if the measures are equal, then the arcs are going to be congruent. And that's just definition of congruent. And your closure. Describe the difference between a central angle and an inscribed angle. How do their measures compare to one another?